Hello, this is the 8th video on the Network Dummy channel, and today we'll be going over OSPF again. This is part 2 of OSPF. OSPF is an important concept you should understand if you intend to pass your CCNA. This is the network topology we'll be working with in this video. We'll be working with 5 routers in today's video. As you can see here in the problem statement, there's only one question that you have to accomplish to complete this exercise. Question 1. Ensure that the route table of router 0 has routes to every network address in this topology. Like the previous exercise, you should first try to solve it yourselves, and if you can't, that's alright, I'll give you the answers right now. These are the steps required to establish an OSPF area for each router. Firstly, as these are Cisco routers, you need to ensure that the routers are all in no shutdown states. I'll attempt to do so right now. To ensure that we speed up this process, I've already went ahead and assigned the no shutdown command to each router, as it is an extremely simple task to do, and I don't think that you need help with it. Okay, now that that's done, let's move on to question 2, assigning it a loopback address. Assigning loopback address in OSPF is considered best practice as it satisfies two factors. Firstly, loopback addresses are virtual interfaces. Imagine a scenario where a physical port goes down, and you are attempting to send traffic towards that specific physical port. The traffic would not be able to reach the targeted device due to the port being down. However, with a virtual interface, the traffic will always make it provided that there is a route there, which can be achieved with a backup redundant link. Secondly, this makes it easier for an administrator to determine which router will be the DR and BDR in an OSPF network. A DR and BDR are routers in an OSPF network that keeps up to date of every other OSPF router state in the network. This heavily reduces network overhead, and it is a big contributing factor as to why OSPF is so efficient. The command to assign a loopback address in OSPF can be done by going into the loopback interface and then simply assigning it an IP address. I'll show you it right now. We'll go to router 0, we'll go to the CLI, and we'll be in global configuration mode. We'll go to the loopback interface, which is int L0, and now you assign it an IP address. With the command IP address 1.1.1.1 255.255.255.255. Now to prove that I've configured the loopback interface, I'll use the command do show int brief. Do show IP int brief. And as you can see here in the loopback 0 interface, the IP address of 1.1.1.1 is assigned. Now I'll do the same for the other routers. For router 1, an IP address of 2.2.2.2 is assigned to it. For router 2, an IP address of 3.3.3.3 is assigned to it. And now in router 3, I've assigned the IP address of 4.4.4.4. And lastly, an IP address of 5.5.5.5 on router 4. Thirdly, we'll create an OSPF process ID to carry out OSPF commands in our network. This can be done with the command router OSPF number. It can be any number. And as you can see here, we've entered a new configuration, config router, which proves that we are in the router OSPF process ID. Just a heads up, this number does not have to be the same across all router, as these process IDs are local to that specific router. To prove that, I will now assign a different process ID to each router. For router 0, I've assigned the process ID of 1. For router 1, an OSPF process ID of 2. And for router 2, an OSPF ID of 3. And I'm sure you get where this is going. Router 3 gets an OSPF process ID of 4. And router 4 a process ID of 5. Now that that's done, we'll move on to step 4, establishing OSPF area. This can be done with the command network 0.0.0.0 255.255.255.255 area number. We'll use the area as 0. This command network 0.0.0.0 with a wildcard mask of 255.255.255.255 area 0 can be applied onto all OSPF routers. Keep in mind that unlike the previous OSPF process command, this area has to be the same across all routers, otherwise this wouldn't work. So I'll copy that, and I'll paste it into every single router. Lastly, this is specifically for best practice. You don't exactly need to do this step, but I'm just doing this for best practice. For every interface that is not facing another OSPF router, for example in router 0, gig 0/1 and gig 0/2 is down and it does not participate in OSPF neighbors. As a result, we'll be assigning the passive interface command to these two ports. The reason for this is because routers will continuously send hello messages out of their interfaces even if there isn't an OSPF neighbor adjacency. This creates additional unnecessary overhead. To disable the interfaces, all we have to do is use the command passive interface followed by the interface that we want to disable. So for in router 0, we'll disable the interface gig 0/1, gig 0/2, and also the loopback interface. We can do that by specifying the command passive interface followed by the interface. Passive interface loopback 0, gig 0/1, and gig 0/2. Now I'll do this for the other routers. For router 1, as all three interfaces are being used, the only thing that we have to disable is the loopback interface. For router 2, we'll have to disable gig 0/2 and loopback interface. For router 4, passive interface L0 and gig 0/2. For router 3, gig 0/2 and loopback. And that is it for the video today. If you've enjoyed the video, please make sure to like and subscribe as that would massively help the channel. Thank you very much and have a nice day.